Hello and welcome to Gradeup. My name is Ashish Sir and I welcome you all to the fourth lecture, the fourth live session on building materials. Now this is the plan for RRB JE and SSC JE we are doing. Previous to this, we have done the sessions on cement, brick and admixtures. So if you have attended this lecture or watched the video on YouTube, then well and good, okay. Else you can go on the YouTube channel of Gradeup Gate and watch these videos and get benefited, okay. We'll wait for more viewers to join this session. Yes, Vishal Datta, Shiv Prasad, Alok Pratap Singh, good evening. I hope you are ready for the session on concrete. So today's session will be dedicated to concrete and this is the final session we are doing for building materials. After that, we'll shift our focus to the surveying, okay. So as you all know, concrete is a very important part of the building material subject, and in practice also, in practical aspect also, concrete is an important part of civil engineers, okay. Rituraj Maurya, yes, good evening. I hope you are practicing the daily quizzes, okay, daily quizzes which are being posted on the RRB plan. It is available in the description, okay. You should attend those also. The test series, if you want to purchase, you can. It is quite an elaborate one. And also, if you have any queries or questions, then post on Gradeup app and tag me, okay, tag me. I'll try to resolve your queries as soon as possible, okay. So I think we should start today's class now that a healthy number of the viewers have joined this session. Okay, so first of all, in concrete, you all know there are two things. One is the nominal mix and second one is design mix, okay. So one is the nominal mix and one is the design mix, okay. So nominal mix are generally for grades less than M20 and this is for grades higher than M25 and above, okay. So it is suited for grades less than M20 including M20, okay. This is for M25 and above, okay. So nominal mix are generally M7.5, which is now rarely used. It is only used for screening purposes, okay. Then there is M10, M15 and M20. Now as you all know, what does this M signifies? It signifies mix and this is 28 day. I think it is not visible, okay, let's not use this pen. So this is M7.5, okay. So M here denotes mix, okay, now it's clear, and this 7.5 here signifies 28 days compressive strength, okay. So M7.5, 10, 15 and 20, only these are the nominal mix grades, okay, while grades greater than M25 and above are this design mix. Ajay ji is saying that design mix M500 is possible. So it may be possible, but it is not in use, okay. Only M60, M65 and that too are suited for the pre-stress. So M500 is very impractical, okay. Now M7.5 for nominal mix, you use ratios of cement, sand and aggregate, okay. So this is the rough proportions, Okay, 1:2:4, 1:1.5:3, and 1:1:2. Okay, so in examinations these ratios can be asked in form of objective questions. Okay, so you should remember these. Okay, so this is some basic information. Okay, let us basic information. Okay, so this is some basic information which I have given you. Now since we are studying from the examination point of view, so I'll skip the content which is not relevant. Okay, so you don't need to worry that I'm skipping something. Okay, that is done intentionally because such information is irrelevant from the examination point of view. Okay, now there are two things which you have often heard. One is bleeding of concrete, and second thing is segregation. So there is a lot of confusion in this. Often objective questions also appear with respect to this. Okay, so now in bleeding is if excess water comes to the surface of concrete, so what will happen? It will cause small pores. Okay, and these pores will reduce the load carrying capacity, because these will leave voids in the concrete volume. Okay, so that means these will remain the concrete in pores. Okay, these will leave the voids in the concrete pores. So when the load will be applied due to the voids, the load carrying capacity is decreased and the concrete may fail. Okay, so in bleeding, excess water comes to the surface. Now what happens in segregation? It is caused when coarse aggregates separate from fine material, and fine material is nothing but sand. Finer material, that is cement, sorry, not sand, cement. Okay, so here bleeding, the water comes to the surface, while in segregation what happens is coarse aggregate, they get separated from the finer material, and as such the bonding between the concrete is not achieved. Okay, because aggregate has separated from the cement paste. Okay, so the structure will become weak and it will fail. So these two both have the same outcome, that is failure of concrete, but the processes are different. Okay, so please, sir, can bleeding and segregation occur simultaneously? Yes, it can definitely occur simultaneously. If there is excess water, then both will occur, because due to excess water this will come to the surface, and if there is excess water, then and you have thrown it from a healthy height. Okay, if you are placing the concrete by say 2 or 3 meters, then this will separate or segregate. There's some issue that coaching may someone is saying about the ratios. See, these ratios are as per the IS codes. Okay, in IS 456 also you have read that nominal you can find that for nominal mix M20 maximum grade is M20, and grades higher than that are design mix. Okay, okay, so now there are some important note. Okay, so now note is, first is with respect to batching. Now what is batching? Okay, there is one important note. Now batching is, it is a process of measuring ingredients to produce good quality concrete. Okay, required to produce concrete. So you have to choose the appropriate proportion of cement, sand, coarse, the aggregates, admixtures. Okay, so that comes under the process of batching. Okay, then there are two processes of batching. Okay, one is weight batching, the second is volume batching. Okay, so there are weight batching and volume batching. Now this one is the superior one, because for this you don't have to take care about the bulking of sand. Okay, while in this case you have to take care of bulking of sand. Okay, so this is superior, hence it is generally preferred one. Okay, so it is preferred for the batching, weight batching. Okay, then this is about batching. Then there is one point regarding the mixing time. Okay, so as per IS code 456/2000, as per IS 456/2000, the mixing time is 2 minutes. Okay, it should be about 2 minutes, but not greater than 3 minutes. Okay, this is the top, this is the highest mixing time which can be done. Okay, so during the mixing 2 minutes is the recommended time as per IS 456/2000. Okay, now something about the curing. Now what is curing? Now it is the process of preventing loss of moisture from concrete. Okay, so there is certain amount of water which you have added in the concrete. Okay, that is for the hydration of the cement and then hardening of the concrete. But if that moisture is lost, then that water will not be available for hydration. So for that curing is done. Okay, it is process of preventing loss of moisture from concrete. Now minimum, from examination point of view, minimum curing period is 7 days. Okay, minimum curing period is 7 days, and recommended curing temperature. These are all codal values. Okay, so they have a high probability of appearing in the examination. So 5 degrees Celsius to 28 degrees Celsius. This is the range. Okay, so this point is important from examination point of view. Okay, this 2 minutes, this is also important. Now weight batching, what happens in volume batching, because there is bulking of sand. Okay, this is important. Bleeding and segregation. Okay, also these ratios are important. So please take a screenshot and we'll quickly move to the next one. Okay. Now water cement ratio. Now for concrete, this term is very important. If you are constructing concrete of a required grade, water cement ratio is very important. Okay, so generally this is by mass. The first thing, if suppose for example, if it is saying that 0.4 is the water cement ratio is equals to 0.4. So what does this 0.4? This is by mass, that is mass of water by mass of cement is 0.4. The ratio is 0.4. Okay. Another thing is, now general range of water cement ratio is 0.35 to 0.65 for good quality of concrete. Okay, this is the general range. Now there are two things. Water, now for hydration, okay, the water cement ratio, which is for for hydration, the required one is 0.23, okay, and for gel water, okay, water entrapped in voids is 0.15, okay. So if I have to give you one water cement ratio which is considered the ideal one, that is 0.38, okay. So for hydration 0.23 is required, and for gel water, that is water entrapped in voids, it is 0.15. So overall for the formation of concrete 0.38 is required, okay. Okay. Now then, many of you have studied and or heard the name Abraham's law, okay. So what does Abraham's law state? It states that compressive strength of concrete is inversely proportional to the water cement ratio. Lesser the water cement ratio, more is the compressive strength, but there is a condition, provided mix is workable, okay. So this is the condition which is to be fulfilled. You cannot reduce water cement ratio by a certain limit, okay. If you keep on reducing the water cement ratio, then workability will be affected. So you have to choose an optimum value of water cement ratio. So if you decrease water cement ratio, the compressive strength will increase, but workability will be reduced. So you have to make a judicious choice, and the optimum value of water cement ratio is fixed such that you get required strength but also get required workability, okay. Now there are certain important points with respect to the compressive strength, okay. Now the first among these is that cube specimen has 15% more strength to cylindrical specimen, okay. So the cube specimen, the size of cube is 150 mm, while if you take cylinder, it is 150 mm dia and 300 mm length, okay. So the cube specimen has 15%. कौन सा कमेंट? अच्छा अच्छा. Cube specimen has 15% more strength to cylindrical specimen, okay. A lot of you are commenting regarding the nominal mixed ratios are wrong, okay. See, M5 is no longer recommended, okay. It is, the minimum grade has been taken out to be M7.5. So 1:4:8 it has been removed, okay. So M7.5, that is 1:3:6. This is the minimum which is used now. M7.5 is no longer used, okay. So M7.5, M10, M15 and M20. These are the 4 grades which are for the nominal mix, okay. Any further query, I will definitely take up in the comment section of comments of the video, okay. Right now we'll focus more on the further content. Okay. Now there is one more thing, that if air voids increase, okay, the strength will reduce. Strength will reduce. Now these points, they appear in form of statements. You will be given in the MCQ questions, you will be given 3-4 statements, and from them you will be asked which of the following are correct or which of the following are incorrect. So 1, 2, 2, 1, 3, 1, right, like this. Okay. Still I am getting comments on the nominal mix. I'll definitely take up it. Okay, don't worry about that. Just leave that for the moment, and I'll take up in the comments or in form of in the next lecture. Okay, so do not worry about that. Just concentrate on what is being taught now. I'll just cross verify those ratios. Okay. Now coming to the workability. In the previous lecture, someone was asking, sir, what is workability? In short, I have told you there, but now today we'll discuss in detail. We'll discuss the definition and the various tests. Okay. Now, workability is with which concrete can be mixed, transported, placed, compacted and finished. Okay. So the entire process, throughout these processes, the concrete should remain workable. It should remain in a plastic state, so that it can easily be worked with. Okay. So it is easy for the laborers to work with the concrete. So it has to remain in the plastic form during the process of mixing, transporting, placing, compacting and finishing. Okay. Now in order to measure workability, various tests have been recommended. Please take a screenshot of this one. Okay. Now tests for workability. From examination point of view, these tests are very important. Okay. Very often the questions appear in various examination. Okay. Sir, grade of concrete for rigid pavement. See, it depends on the quality of pavement which you are going to construct. If it is being constructed for highway, then I think M20, M25, M30 will be sufficient. But if you are constructing the same rigid pavement for airports, okay, for the runways and everything, for that you will require greater grades. So M35, M40 may be used. Okay, these are not absolute values, but just on the relative purposes I am explaining you. For highways, for nominal works, these may be used, but for airports, okay, and because they heavy aircrafts land on those, so you will need higher grade of concretes for that. Okay. Now test for workability. Now the first and the most common one is slump test. So I am sure everyone has heard this one. So the slump cone is something like this. Okay. The top dia is 100 mm, bottom dia is 200 mm. Okay, and the height is, this height is 300 mm. Okay. Now here the mold is filled in 4 layers. Okay, 1, 2 and 3 and 4. It will be filled in 4 layers and 25 strokes on each layer. Okay, it will be filled in 4 layers and then this cone will be removed. Okay, after that slump is recorded in slump is recorded in mm of subsidence. Okay, so it is recorded in mm of this subsidence. Height is 30 centimeter. Yes, I have written 300 mm. That is equivalent to 30 centimeter. Okay. Okay. So slump is recorded in mm of subsidence. Okay. Now there are three types of slump which can occur: true slump, okay, shear slump, and third one is collapse. Okay. So true slump happens when if you have removed this one and it was originally in like this, it just subsides by some distance vertically. Okay, so that is true slump. Now what is shear slump? If suppose this was the original case, it just gets like this. So from one side it has sheared. Okay, that is known as shear slump. And collapse is, it's basically has very high workability. So when you remove the cone, the concrete just flows. Okay, so that is known as the condition of collapse. Okay. Then there is one more point which is important. It is suitable for medium to high workability. It is suitable for medium to high workability. Okay, so it is suited for medium to high workability. Okay, so this is the information. This point is important from examination point of view. Medium to high workability. Okay, these dimensions are important. Okay, please take a screenshot of this. Okay. Now, the second test is the compaction factor. Compaction factor test. Okay. See, some comments I am getting for 3 layers. See, the 3 layers are for the compressive strength test. Okay, in slump we fill in 4 layers. In compressive strength test, which we will be studying in coming in due course of time. Okay, in compressive strength we fill in 3 layers. Okay, in slump it is 4 layers. Now this compaction factor, it is suitable for, this is for medium to low workability. Okay, so it is suitable for medium to low workability. Okay, and what is the compaction factor? It is weight of partially compacted divided by weight of fully compacted specimen. Okay, so this is the information about the compaction factor. Okay, this point is important from examination point of view. Also now, tamping and strokes. Yes, stroke and tamping is tamping rod we use, and with that we give strokes in the concrete. Okay. Now there is an important table, workability. Okay, now it is the relation between slump and compaction factor. Okay, so there is very low, low, medium and high. Okay. For very high, these tests are not recommended. For this, another test, that is flow test, which is recommended. Okay. So slump for very low is 0 to 25 mm. For low it is 25 to 50 mm. For medium it is 50 to 100, and for high it is 100 to 175. Okay. Now compaction factor. So lesser is the compaction factor, lesser is the slump, lesser is the compaction factor. Okay. So 0.25, for this it is 0.7 to 0.8. Okay. For this it is 0.8 to 0.85. This is 0.85 to 0.95, and for this it is 0.95 to 1.0. Okay. So this table is very important. Often questions will appear from this. Okay. Okay. Please take a screenshot of a whole screen. Now we'll move to the next one. Please remember this table. Please study this table thoroughly. Okay. Often you will get questions. Now third test is VB test. Okay. So what does VB measures? It is, first of all, it is, the important point is, it is suitable for very low workability. Okay. It is suitable for very low workability. And then it is recorded in seconds. Okay. These measurement units are also very important. In slump you measure in mm, in compaction factor it is ratio, while in VB it is recorded in seconds. Okay. So time when concrete specimen will assume the cylindrical shape. The cone for this is similar to one used in the slump test. Okay. So you remove the cone and the time when, and give vibrations to the concrete. So by the time it will attain a cylindrical shape, you will record that time, and that is the VB time for the concrete. Okay. Now the fourth and the test which is suited for the concrete of very high workability, suitable for very high workability. Okay. It is suited for very high workability. Now the flow table which is used has a dia of 76 centimeter. 76 centimeter is the dia. Okay. And mold in shape of frustum. Okay. Of bottom diameter 25 centimeter, top dia 17 centimeter, and height is of 12 centimeter. See, flow test you will not get in every content, so I am writing some values in this elaborately so that you can note these down and put it in our memory. Okay. So flow table is of 70 centimeter dia. It is in circular shape. Okay. The mold in shape of frustum of bottom dia 25 centimeter, top dia is 17 centimeter, and height is 12 centimeter. Okay. Now it is filled in 2 layers and lifted. Okay. So after filling the mold, filled in 2 layers and lifted. Okay. You fill the mold and 2 layers and lift it. Okay. Then the table is raised. Then table is raised and dropped by distance of 12.5 mm, that is 1.5 centimeter. Okay, and this is done for 15 times in 15 seconds. Okay, 15 times in 15 seconds. Okay, so the table is raised and lowered by 12.5 mm for 15 times in 15 seconds. Okay, one time in 1 second. Okay, so the spread is measured in 6 directions. Now the concrete will be spread, okay, on the table, on this flow table. So spread is measured in 6 directions. Okay, and the flow percentage will be given as percentage increase of average diameter of spread, average diameter of spread over the plate, this table base diameter, that is 76 centimeter. Okay, and this value is generally between 0 to 150 percentage. Okay, for this much high workability, very high workability, all other tests are unsuitable and we use flow test. Okay, the procedure is somewhat this, and it is represented in percentage. Okay, now see, this is recommended in percentage, compaction factor was in ratio, the slump test was in mm, and VB is in seconds. Okay, so these all points are very important. From here, this is the most important one. It is suited for very high workability. So you can be asked even in the form of match the followings, which test is suitable for which one. Okay, so I hope this is clear. Now this was about the workability. Now about the strength of concrete. Okay, now the strength of concrete, the first one is, and the important one is, compressive strength. Okay, so the compressive strength of concrete. Now in compressive strength, we use a cylindrical specimen of length to dia ratio. Dia ratio 3:1. Okay. Also, in this cylindrical specimen, the concrete is filled in 3 layers. Okay, of 5 centimeter. It is filled in 3 layers of 5 centimeter. Okay, and tampings are given to these one, that is 25 tampings each. Okay, also the important thing here is temperature is kept to be 27 plus minus 2 degrees Celsius. Relative humidity is 90%. Okay, then the sample is removed. Okay, it is put in the water for 24 degrees Celsius. Okay, it is put in the table for 24 hours. After then it is removed and cured. Okay, and tested in universal testing machine, UTM. UTM is universal testing machine, and loaded at the rate of 14 Newton per mm square per minute. Okay, so this is the, and the strength, the load is calculated, and the cross sectional area you know. So with that you can calculate the 28 days compressive strength. Okay, so at various days the strength can be calculated. So at 3 days, 7 days, so you will construct several samples. Okay, so at 3 days you will take a sample. Okay, and at 7 days you will take another 3-4 samples and take the average values, and at 28 days you will take sample. So that will give the 28 days strength. Okay. So this is also one more thing, that 7 days strength is approximately, 3 day first, 3 days strength. So three days strength is roughly about half of 28 days compressive strength, and 7 day strength is roughly about 2/3 of 28 day strength. Okay. So these 2 points are also important from examination point of view. Okay. Now this was about the compressive strength test. Now the second is tensile strength. Now since the tensile strength is not very much of concrete, concrete is a brittle material, it does not have much tensile strength. Okay. So these tests are not very important from that point of view, but we will definitely see. So one test is flexure tensile strength. Now for this we apply 2-point loading. A simply supported beam is constructed of concrete, okay, and we apply unit loading. This distance is x, this distance is also x, and this distance is also x. Okay. So what happens is the bending moment diagram. Okay. Now here shear will be like, shear diagram will be something like this. So in the middle zone, this will be having a pure bending case. Okay. So with this the flexure tensile strength is given. Also the formula to that is 0.7 under root FCK, which you all know as the modulus of rupture. Okay. So this gives that information. Okay. Now this is about the flexure. Then there is also splitting tensile strength test. Now splitting tensile strength test is conducted like this only, the compressive strength test, but this, in this case, it is loaded along the diameter. Horizontally it is loaded. Okay. If suppose this is the cylinder, you will load like this. Okay. So in this length case, it is having compression, but in the this cross section it is in tension. Okay. So that will give the this splitting tensile strength test, and the formula which 2p upon pi dl, which is associated with this strength, is 2p upon pi dl. Okay. Now the mixed design of concrete, someone was asking about the yield of concrete. Now yield of concrete is nothing but the output if you have mixed the ingredients. Now what is the output of that one, of those ingredients? Okay. So the what is the output of the concrete, that is known as the this yield of concrete. Now there is from objective point of view, mixed design process is not important, but because it cannot be asked in detail, it is more important for the conventional point of view. But the basic procedure you should remember. Now the IS code for this is 10262, and it is published in 1982. IS 10. Okay, it is not very clear. (10262) 1982. Okay. Now the steps I will write. Okay. So first thing is you find the F mean, target mean strength, that is FCK plus 1.65 sigma. Okay. So using this you will using the target mean strength you get water cement ratio. Water cement ratio. Okay. You get the water cement ratio with workability requirements. Get water content using workability. Which type of workability is required? You get the water content. Now using these two, step 2 and 3, you will get cement content and also assume ratio of fine aggregate to coarse aggregate. Okay, and with the absolute volume principle, which states that mass of cement upon density of cement plus mass of fine aggregates upon rho of fine aggregates plus mass of coarse aggregate upon rho of coarse aggregate plus volume of water plus volume of voids is equals to volume of concrete. So using this equation you will get the weights. Okay, so finally determine weight of ingredients. So this is the mixed design procedure. This steps can be asked to you in objective point of view in small points. So I hope this is clear. What is the difference between tensile strength, split tensile strength and flexural tensile strength? See, tensile strength is when you apply the tensile load and the material is resisting that load. That will give you the tensile strength. Now it may be of different types. Now split tensile strength is one such part. Okay, it is one such entity. So if suppose this is the cylinder and you are applying the compressive load in this direction from here length. So this cross section will be in tension, but this diametric, this cross section will be in tension because the compressive stress in one plane will apply an equal, and due to the Poisson's ratio it will apply an stress of opposite sign in the perpendicular direction. So in this direction it will be tensile. So that will give the split tensile strength. What is flexural tensile strength? You have used a simply supported beam and applied a 2-point loading. So that will have, this is the shear force diagram of this one. This is positive, this is negative. So you can see in this portion there is no shear, there is only bending in this case. So it will be pure bending, and bending and flexure are one and the same thing. So this is flexural tensile strength or bending tensile strength. Okay, so I hope this is clear to you. So this was the content about the concrete. Now we'll move to the questions. Please take a screenshot of this. Okay. Now this is the first question. On your screens. So if you have followed the lecture carefully, you should be able to solve this question. Now in this question, you have to assume a simple point. From objective point of view, you have to assume a simple point. Now there is split tensile strength and flexural tensile strength. But because both are small values, so for solving this objective question, you have to take a small assumption that let split tensile strength of concrete be approximately equal to flexure tensile strength. Okay, so we are assuming that because there is no set formulas. There is the formula for split tensile strength, but we don't know the experimental values. While flexural tensile strength is given to you as per the IS code. Okay, so it will be roughly equal to the 0.7 under root FCK. So the formula in form of FCK is available to you. Okay, now you are required the split tensile strength of M15 grade as percentage of its compressive strength. Okay, so the entity which you required are 0.7 under root FCK upon FCK into 100%. So for M15 the ratio is 0.7 under root 15 divided by 15 into 100. So if you solve this, okay, the value which you will be getting is roughly about 18%. Now from the options, there is option A is 10 to 15, 15 to 20, 20 to 25, 25 to 20, 25 to 25. Okay, there is something wrong with the D option, but let it be. Okay, so 18 C. So you are getting the value 18. So the appropriate range, the best among these options would be 15 to 20%. So that is B option is correct. Okay. Okay. So I hope you have got this solution. Okay. Now we'll move to the next question. Now it is theoretical one, but since I have taught you about the wave batching and volume batching, you should be able to solve this question. Now wave batching proceeds on the assumption of declared weight in each bag of cement, weighing the content of each bag, accurately estimating the weight of each material to be used in each bag, and the assumption of correct dry weight of water. Okay. So please quickly. Post your answers. Option A, the assumption of the declared weight. See, wave batching is not based on the assumptions. So option A cannot be the answer. Okay, it cannot be the answer. Weighing of the contents of each bag. It is also not very apt one. The assumption of correct dry weight of water. No, there is no assumptions involved. So the answer to this is C. Okay. Accurately estimating the weight of each material to be used in each batching. Okay. So that's why we are preferring volume batching over. Wave batching over volume batching, because in volume batching we have to take care for the bulking of sand. So that will bring inaccuracies to the batching process. So here we are using wave batching because it accurately estimates the weight of each material to be used in each batch. Okay. Okay. So next question now. Identify the wrong statement in this. Okay. Now bulking of sand. This bulking of sand you would have also studied in the soil mechanics. Okay. So bulking of sand can go up to 40%. Yes, this is correct. This is correct. Okay. Bulking of sand is maximum at 4 to 6% of moisture content. Yes, this is also correct. Bulking of sand is considered in wet batching of concrete mixes. Now this is not correct. Bulking of sand occurs due to free moisture film formation over sand. Yes, this is also correct. So bulking of sand is considered in not weight but volume batching. Okay. In wave batching it is not to be considered. In volume batching you have to take care of the bulking of sand. So option C is the correct option because it is wrong one. Okay. Okay. Next question. This also I have told you in the lecture itself. To estimate 28 days crushing strength, we multiply the 7-day cube strength by. I have told you that 7 day strength is approximately about 2 by 3 times of 28 days strength. Okay, the factor by which the 7 days to be multiplied will be 1.5 times of 7-day strength will give you 28 days strength. Okay, so these are not absolute ones, but on an approximation these can be said. Okay, so the correct option to this question will be C, that is 1.5. 3, 2.5, 1.2 all are incorrect. Okay. Now next question. This is also I have explained. The modulus of rupture of concrete gives A, the direct tensile strength of concrete, the direct compressive strength of concrete, the tensile strength of concrete under bending, and the characteristic strength of concrete. Now the first option, if I go option by option, the direct tensile strength, this is incorrect. It does not give the direct tensile strength because we are not applying the direct loading. We are applying the indirect loading, that is flexural loading. Okay. The direct compressive stress, no, this is incorrect because it gives tensile strength, not the compressive strength. If we talk about the option D, the characteristic strength of concrete, no, it does not give the characteristic strength of concrete. So option C is the correct answer to this question. Okay. Okay. Next question. Now consider the following statement in a typical compression test with a concrete specimen. Cylindrical concrete specimen. Failure is initiated by. There are 3 failure modes: crushing in compression, inclined shear failure, and longitudinal shear cracks. So which of these will occur in the concrete specimen? Okay. Just post your answers. Till then I will be writing the content here. See, concrete is a brittle material. The solution here is slightly linked to the strength of material or solid mechanics. So concrete is a brittle material, and we know brittle material when subjected to compression. So if suppose this is a brittle material and it is subjected to compressive forces, the failure will be in form of inclined, this is 45 degree. So the failure will be, this will be shear. Okay. So failure due to shear cracks inclined at about 45 degree. Okay. So answer to this question will be 2, that is B. 2 only, that is only inclined shear cracks. Okay. Since we are using the cylindrical concrete specimen, so crushing in compression will not be occurring here because concrete is very strong in compression. Sorry, concrete is not, but because crushing will not occur because there will be, concrete is weak in. Okay. So in brittle materials, see, concrete is a brittle material, and brittle material when subjected to compression will fail like this. This is the general mode of failure. Okay. Okay. Next question. Oh shit. Just wait for 1 minute. Okay. Sorry. So just read these statements and you have to select the correct, which of the above statements are correct. Now workability increases with the increase in proportion of water content. Yes, this is correct. Then concrete having small size aggregate is more workable than the concrete containing large size aggregate. Okay. See, small size aggregates will have more surface area. Okay, and more surface area will require more cement paste. Okay, so hence less workability. Okay, so this statement is incorrect. The statement 2 is incorrect because small size aggregate has more surface area than large size aggregate. Okay, so it requires more cement paste and less workability. Okay, now third statement, for the same quantity of water, rounded aggregate produce a more workable concrete mix as compared to angular and flaky. Yes, it is correct. Okay, rounded aggregates are more workable. A concrete mix with no slump shown in the slump cone test indicates its very poor workability. Yes, definitely it's correct. So option 2 is incorrect, but 1, 3 and 4 are correct. So the correct answer to this question will be C. That is 1, 3 and 4. Okay. Going on. Now this question. Okay. So here you are provided with one bag of cement. Okay, that weighs 50 kg. Also we know that volume of one bag of cement is how much? It is 34.5 liters or roughly about 35 liters. Okay, so you are provided with the mix 1, 2, 4 and that is by volume. So 1 is 1 part of cement, 2 parts of fine aggregate and 4 parts of coarse aggregate are there. So 35 liters is cement, that is one part. So 35 liters. So volume of cement is 35 liters. So volume of fine aggregates will be 2 times of 35, that is 70 liters. Similarly, volume of aggregates is 4 into 35, that is 140 liters. Okay, so from the options you can see option D is the correct answer. Okay. Longitudinal tensile cracks won't be there because concrete is weak in tension. There won't be any longitudinal tensile cracks. It will just break. There won't be any cracks. Okay, you know from the RCC you can definitely see. Then only we are requiring the reinforcement. The tensile strength is to improve the tensile strength of concrete. We are using the reinforcement, longitudinal reinforcement. Okay. Okay, moving on. This is about the maturity of the concrete. So here curing temperature is 11 plus 15, that is 26 degrees Celsius. Curing period is 28 days. Okay, so maturity, as we know, it is equal to curing temperature by curing period. So it is 26 into 28, that is 728 degrees Celsius days. Okay, so option D is the correct answer. So maturity is given by curing temperature into curing period. Now here you are given with concrete sample is cured at 15 degrees Celsius and original temperature 11. So curing temperature is 11 plus 15, that is 26 degrees Celsius, and curing period is 28 days. Okay, so I hope this is clear. Now moving on to the last question now. Now here this is related to the stripping time of formwork for concrete. Okay, so in order to solve this problem you will require some information which I am writing here as per IS 456-2000. Okay, the stripping times are as under: for vertical formwork it is to be removed 16 to 24 hours after casting. Okay, then soffit to slabs. Soffits are bottoms Okay, soffit, sorry, sides. Soffit is bottom to slabs, but you have to place the props. Okay, this is to be removed in 3 days. Okay, now soffit to beam. Okay, now soffit to beam is to be removed in 7 days. This table you can find in the IS code also. Okay, slab bottom for span up to 4.5 meter, it is 7 days. Then slab bottom for span over 4.5 meter is 14 days. Then beam bottom for span up to 6 meters is 14 days, and beam bottom for span over 6 meter is 21 days. Okay, so this information you will find in IS 456 also. Okay, so if you solve this, this is the data, and with this if you solve this question, you will get the option. Yes, Anurag, you have solved it correctly. Answer is A. Okay, answer is A. Now a 14 days, it is with respect to removal of props to slab spanning over 4.5 meter. Yes. Okay, then B is B is 21 days, that is for removal of props to beam spanning over 6 meter. Okay, over 6 meter. Then there is C, that is 3 days, and it is with respect to slab props left under slabs, and 7 days is with respect to 3, that is beam soffits. Okay, so this was the last question. Please take a screenshot of this one. You can also find this in the IS 456 also. Please read for once, read IS 456 2000 thoroughly. Okay, there are a lot of questions which are formulated from that. Okay, why add temperature? See, in that question you have to add that information, because the concrete is cured at 15 degrees Celsius and original temperature is the original temperature of the concrete was 11 degrees Celsius, and you are curing at this temperature, so you have to add this for getting the curing temperature. Okay, so thank you for watching this video. This was the last for the building materials. Now in the next lecture we'll move to the surveying. Okay, and we'll study the first topic, that is linear measurements. On Friday at 6 p.m. it will be held. Okay, so join that session, and till then keep practicing. Okay, keep preparing. So thank you for watching this video, and have a great day ahead.